So in this tutorial we're going to have a little look at how you might obtain speeds and feeds for your CNC sequences that we've been creating in the previous tutorials. So this is taken from the perspective of someone who doesn't have any prior knowledge of what might be a reasonable speed and feed. And when I say speeds and feeds, I mean the speed of the tool when it moves in X and Y axes mainly. That can include the Z-axis as well, so the Z-axis is the vertical, but you generally refer to feed in terms of X and Y movements, and the speed in terms of the rotational speed of the tool. How quickly is the CNC machine spinning the tool in the end of the turret or the end of the chuck. Mixed in with these two values are other values that have an effect on them, and these could all be kind of classified as the cutting parameters. So the specifics of how quickly the cut occurs, how deep the cut is, so how deep is the tool into the material, and how much the tool steps across sideways in subsequent cutting passes. So in order to look at these issues or these topics, we're going to use our manufacturing assembly that we've used in our previous tutorials. So you can see that on the screen here. If you haven't done the previous tutorials, I suggest you go away and do both of those first. So if you need to find them, here they are on the shoe site. So there's the intro to CNC machining in Creo, and there's the continuation. So each one of these videos is around an hour long. If you're new to the machining interface in Creo, it would probably take you considerably longer than an hour to perform all the steps in each one of these. But I would certainly say do both of these tutorials before you move on to this one. Because we're kind of using those two tutorials as our basis for putting in some machining parameters. So with all that being said, let's get on with the task in hand. So what I'm going to do, I'm going to just go into the properties of this face mill that we created first to remove the material from the top of this stock block. I'm going to go in there, edit definition. I'm going to see what tool has been currently set up. So if you remember back when we set this sequence up, we just created a tool in the tool table. So I'm going to go in and edit tools just so I can see the properties of this face milling tool. So the face milling tool is kind of a specific little subset of an end mill. It is essentially an end mill. They can also be classified as bull mills, some face milling tools. That is if they have a slight radius on the corner. But as far as Creo is concerned, the geometry of the face mill is just kind of cylindrical with a radius on sometimes, or cylindrical with just a flat face on the end. So in our case, we're going to assume this end mill has got a flat face. We then created a common diameter of face mill that is freely available. And what we're going to start to do now is to research whether this tool geometry that we've entered here and the cutting data that we haven't yet entered, we just accepted the default that the system decided for us. So whether all of this data, the geometry and the speeds and feeds and the depths of cut and the step over distances are reasonable values. And to do that, we're going to go to a large tool manufacturer's website. Specifically, we're going to use the Sandvik website. So if you need to search for this, it's Sandvik Coromant is the search term that you want to put into your search engine. And this is kind of the homepage of their manufacturing arm for CNC cutting tools, or for milling and turning tools. And this is a particularly good site because they're the manufacturer of the tools, so they're not just a reseller. Resellers often, or wholesalers often will provide you with cutting data, but it's better to get it from the actual tool manufacturers themselves. So in this case, we're looking to get some info on a face milling tool. So let's have a look in here. So if we go to tools, it is milling tools specifically that we're interested in. Obviously turning tools would be to do with lathes and that sort of machining. It's face milling tools. We've already said this is a face milling operation. We don't really have any prior knowledge of what all these tools are, but let's start with the first one in the list. First choice for mixed production. Sounds good. Then we get a little bit of information about this range of tools, and if we go into the assortment tab and then browse down to tool items and then milling cutter, you can see there's 97 variations of this particular tool, this Creo Mill 245. And before we get in here, it's worth just looking at the tool here, just seeing physically what this tool looks like. It's what's known as a tipped tool. So the tool body itself does not do the cutting. These extremely hard material tips get bolted to the tool with these little Torx head bolts, and it's the tips that actually do the cutting or the material removal, which is a cost-effective way of building these tools. So you retain the tool holder and you just buy new tips when they're blunt. So let's go in and see what sorts of diameters, cutting diameters to begin with, we're going to look at. So there's a 32mm version of this tool and a 40mm, and then these seem to be kind of increasing in diameter. Yeah, so let's go back to what we'd set our tool as. So we'd set ours as a 35mm tool. So let's modify our tool to match this tool here, this specific variant of the Sandvik face mill that we're going to use. So it's 32mm diameter, so we can enter that in. So this is a specific tool, 32mm, maximum cutting diameter, maximum depth of cut we have as 6mm, so that would be essentially the height of the cutting surface, so it can't cut any deeper than 6. If we then go in and kind of browse a little bit more detail about this tool, so I'm just looking at this on the other screen as I'm entering some of this data in. So I can see that the overall length of the tool is 117mm, so we obviously have to account for a portion of it being held by the holder, so maybe the maximum extent that this tool could stick out, being quite conservative with this value, would be, say, 60mm. The type of holder that this tool will fit into, well, it'll fit into multiple types of holder, so we would have to then research common holders for the tool. So these two values are not included by Sandvik. We would have to go to a tool holder manufacturer to get those values. But this tooth height or cutting height, this diameter, and this extension of tools stuck out are now based on some real world values of a tool that we know is available. So if I apply those values now, it will kind of ask me to confirm that, and then you can see those values updated there. So now what I'm going to do is to try and get some cutting data. So this is the speeds and feeds portion of our cutting parameters that we need. So while I'm browsing this tool in the Sandvik website, one of the tabs that I can click on is calculate cutting data. And then that takes me through to a section of the Sandvik website which is incredibly useful. So this is the full tool guide that allows you to enter some data about the sorts of cuts that you're trying to perform, and the tool, the Sandvik tool specifically that you're using, and then their algorithms and their cutting data tables will give you suitable speeds and feeds and cut depths and other cutting data, which is quite useful. So you can read through the introduction pages here, which is probably a good idea if you're new to this tool, or you can just cancel that. So one of the things that you have to set is what sort of material you're cutting. These are broadly arranged into kind of broad categories in terms of what the material is, and then a hardness value, so a Brunel hardness value. So let's assume we're cutting just standard low alloy steel, and then let's move on to the next option down here. So what are we trying to machine away? We're just trying to machine away just a plain surface. So seeing as we're doing just a simple face mill, we just have a block of material that has a single face on the top of it, and we're just trying to machine that face to be slightly lower into the material. So plain surface. One of the next things that it has automatically filled in for us is what is the specification of our CNC machine. So if we want to set some specifics here, we have some kind of default machines that we can use here in terms of the power of the machine in kilowatts, the maximum rotational speed, things like that. So we can select one of these. But generally it chooses a default for us, but just know that you can actually set those values. So now what it's asking us, depth of the machining feature. Well, if you've done the previous tutorials, you will know that this face mill takes 3 millimeters of material off the top of our stock block, so we can enter that in. 3 millimeters is the depth of the machining feature. The general width parameter, this little graphic on the right hand side kind of gives you an indication of what that means. In our case, that is the width of the block, which I believe is around 86 millimeters in our case. The general length parameter, so again it's the approximate length of our block, which I think in our case is up around 125 millimeters long, something in that kind of vicinity. So then when I filled all three of those kind of prerequisites in, I can click on Get Results, and then it already knows that I'm inquiring specifically about using the Coromil 245. So it's giving me a cutting speed in meters per minute here, and it's giving me a feed per tooth. Now I could then convert those into the units that I'm using in Creo, which is millimeters per minute, and not feed per tooth but RPM. But if I click on Show More Detail here, I should get a bigger table form of what we were just looking at. So in terms of the spindle speed here, it's telling me to set the rotational speed to 3410 RPM. So I can do that now. So I can do that for the tool itself, which is probably a good idea, or I can set it for the actual operation that I'm trying to use that tool for. Because obviously your tool table, when you're setting up these sequences, these milling sequences, one tool may be used for multiple different sequences. So the speeds and feeds in each sequence might be different for a single tool. So you can set the sort of average cutting data for the tool in here, but in our case let's set it for the specific face milling sequence. So I'm going to OK the modifications that we made to the dimensions of the tool, like that. And then I'm still in the face milling sequence at the moment. And then if I go into parameters, I can set the spindle speed here. So what was it that we got as a recommendation? We got 3410 RPM. And the cut feed is coming out at, here it is, millimeters per minute is the units that we're working in inside Creo. So it's 4060. So if I set that now, 4060. And then other things which may be useful to us in here, the depth of cut, the number of passes. In this particular example, I don't think that we'll set these specifically. We'll see what Creo comes up with, and then we may refer back to these slightly later. So the toolpath now will have updated, and if we want to run a material simulation on that now, we can. So I'll slow this down because it's a relatively simple operation. So yeah, that achieves what we need it to achieve. And now, rather than just estimating these values, estimating the dimensions of the tool itself, and estimating the cutting parameters, so the speeds and the feeds, we are actually basing this tool and this specific machining sequence on real world data that we could then reference. If we were writing a report of this CNC program, we could include a reference to the tool that we were using and where we obtained the cutting data from. So now it might be nice to do the same kind of exercise, but for one of the other milling sequences that we have in this assembly. So I'm going to go in and see some of the setup of this volume mill. So this was the volume mill that addresses this kind of volume of material here. So I'm going to go into the volume mill, edit definition, see how the tool is set up in here. So this is tool 2, edit tools. So I've set this up as a bull mill, 50mm diameter external with a 5mm radius on the bottom. So if we go back into the Sandvik website and go into tools, milling tools, and then browse all the milling tools, let's see if we can find something suitable to do this job. So I suspect we might find something in profile milling tools. And then if we browse through a few of these to try and find one that's suitable, what I might end up doing is maybe switching this to a ball nose style tool. So if I click on ball nose and then go into assortment, down to tool items, browse to see the full range that's available in here. So mine was a 50mm cutting diameter. So if we try and get something close to that, there's a 16mm here which might work, or maybe a 12mm. Let's try the 16mm to begin with. So we've got our general cutting data there. So if I tool geometry, sorry, there. So if I just take that onto the other screen for a second, and I can change this type of tool to a ball mill style tool, and then modify the cutting diameter so that it matches the actual tool. The tool that's offered by Sandvik, what is the maximum tool length? The functional length is 200mm, so I think it would be more than acceptable to put half of that length out of the end of the holder. It still leaves us 100mm to actually clamp inside the holder. As I've already said, the holders, common types of holders are BT40. So BT40 is a common type of tool holder, and we would have to get the geometry for the maximum diameter of that and the typical height from elsewhere. But that's a simple search for BT40 tool holders or similar styles of tool holders. The maximum cutting depth, depth of cut maximum is 14.4 for this tool. So yeah, we filled in the tool geometry there. So if I click on apply, it's not allowing us to override the default type. So maybe what I'd have to do in this case is create a new tool for this particular milling sequence. It's a ball mill. Enter my data in again. So the maximum depth was 14.4. I decided my tool holder was going to be 100 tall and 45 wide, and then apply. One nice thing that you can do in here is modify the actual default name of this tool. So if we're using a specific tool from a specific manufacturer, then maybe we could just paste the name of that tool into the box. I think one thing that we will have to be careful of here is we probably are not allowed to put spaces in the actual name of the tool. So I'm just editing that text that I put in there to get rid of any spaces that might be in there, and there you go. The tool ID is now being changed to this specific Sandvik type of tool that I'm using. So if I OK that now, and then I go into parameters, obviously we've done this before, we're looking for speeds and feeds. So here's my tool that I'm using, calculate cutting data, and then we'll have to fill in the relevant information before we can get the cutting data recommendation. So the area of the surface to be machined, so I could measure the distance along this curve here, but let's just put a value in there. So let's do an estimate. So in order to estimate some of these values, I'm going to temporarily pause what I'm doing in the volume milling tab and go into the analysis tab. I probably want to hide this extruded volume here, so there it is, hide the extruded volume, get my measurement tool, and I can measure various values here. So the area of the faces that I want to tackle, it's probably worth hiding the workpiece as well. So this face, this face, this face, this face, and this face is an approximation of the area that I want to tackle. So let's call that 1200. So I'll put that value in on my setup page here. So I've put 1200 in there for the area that I want to tackle. The depth that I'm interested in, so if I could just get the normal measurement tool, the distance measurement, so from here to here, distance is just over 13.5 millimeters. So I'll enter that in as well. Tool axis angle to surface, so I suspect that will be 90 degrees. Allowance depth of cut, so I'm just going to enter a millimeter for depth of cut, and then the roughness value of the surface that I'm willing to accept. And when I've set all these values as I need them, I can then get my results. And then show further cutting data detail. So we have a feed of 5150. So if I now go back into my volume milling tab and resume this feature, so because I came out of that feature and started measuring things, I have to shut the measurement window down, resume the feature by clicking here, and then I'm free to go in and start setting some of these values. So we've got 5150, and then for spindle speed, so here's our spindle speed, 9160. Like that. So in that way we can create our overall CNC program and the specific sequences themselves with actual real world values rather than just accepting the default values for speeds and feeds that Creo generates, and rather than making up the tool dimensions that would be our ideal tool for the job. We are actually basing our tool dimensions on real world tools. And if again we were writing a report of this, we could take copies of the cutting data that we've been supplied with. We could take copies of the actual tool data itself as well. So if we can get this tool data open, there's the tool data. So we could have copies of not only the geometry data and the specific cutter that we're intending to use, we could also have the cutting parameter recommendations as well, so the speeds and feeds. So yeah, the Sandvik website is a very good resource for getting all this data so that we can base our Creo programs, our Creo CNC programs, on that real world data.